Hi, welcome to another video on my YouTube channel. For this video we'll be looking at the quadratic function and specifically the expression in the quadratic function. So the overall function is a relationship between x and y, right? But for this video we'll be looking at the expression aspect, which is basically ax squared plus bx plus c. So for this first video I will cover two objectives, which are to define what is a quadratic expression and to factorize quadratic expression, and objectives 3 and 4 will be covered in two additional videos, right? We will be looking at how to solve quadratic equation using factorization and also solve quadratic equation using the quadratic formula. Now let's move into it. What is a quadratic expression? Alright, let's take this off. What is a quadratic expression? Now, a quadratic expression is an expression in the form ax squared plus bx plus c, where a is not equal to 0. Right? So let me put that down here. So any equation you see, that is any expression you see in this form, ax squared plus bx plus c, that is basically a quadratic expression. And what makes this a quadratic expression is this number here at the top. If you look at all the expressions, the highest power is actually a 2. Right? So once you have a power of 2 as being the highest power, then that is a quadratic expression. If it's a case where you had something like ax plus b, right? This x has a degree of 1. So this would not be a quadratic expression. Has a degree of 1, that's more like a linear expression. And if you see something like ax cubed plus bx plus c, then due to the fact that this is a 3, so this would be referred to as a third degree polynomial. So this wouldn't be a quadratic expression. So what makes it a quadratic expression is mainly this square at the top. So the square, so the highest degree is actually a square. There is no power in it higher than the 2. So this makes it a quadratic expression. Alright, let me get rid of this. Okay, so when x plus 4, when open bracket x plus 4 times close bracket x plus 2 is expanded, it gives the quadratic expression, this expression x squared plus 6x plus 8. So this is basically saying that whenever you expand x plus 4 and x plus 2, it will give you x squared plus 6x plus 8. And if we should apply the expansion here, right, let me just give you a little illustration so you can know what is happening. So we multiply each term in each bracket by every term in the other bracket. So x times x would give us x times x plus x times 2, so that covers the x, plus 4 times x plus 4 times 2. So this gives us x squared plus 2x plus 4x plus 8. Right? And if we should clean that up a bit, we'll get x squared plus 2x plus 4x would give us 6x, and we have a 8 remaining, which is what we read. So what this is basically saying, if you expand these products right here, you would get this quadratic expression, x squared plus 6x plus 8. So we can also do the reverse process by starting with a quadratic expression. So similarly to how you started with this first, and then you got this, we can also do the reverse, where we start with x squared plus 6x plus 8. And if you should perform the reverse, you would get back the original x plus 4 times x plus 2. Right? So this is basically what we'll be going into for the next slide. So I just want you to get those two ideas so you can know when we are moving between. Okay, so the process of moving from what we had earlier was this. Let me bring this back. X plus 4 times x plus 2. And we also had x squared plus 6x plus 8. And as I said, we can move between these two. Let me just put these arrows right here. Right, so originally we got the products. We got these two products, and we expanded these brackets, and we got this quadratic expression. Similarly, you can also take this quadratic expression and move to this form as well. Right, so this arrow should be, move to this way as well. So that's what we're basically going to do, and this process is called factorization, right, where you factorize a quadratic expression. And whenever you hear of factorize, it's basically a case where you write a number or a term in a different way, so that when you multiply them, you would actually get back the original number or the original term. So for example, if I say we should factorize 6, 6 should be written in a form where it involves factors of 6. Now, what are the factors of 6? We have 1, 2, 3, and 6, right? So all those numbers can go into 6 without leaving a remainder. And we can do this by having 2 and 3. Let me put 2 and 3. 2 and 3. But whenever you multiply 2 times 3, it is equal to 6. So it's the same concept that we had earlier. Whenever you multiply these two products by themselves, you would get the quadratic expression, right? And you can also, just like how you split the 6 and turn it into 2 times 3, you can also split the x squared plus 6x plus 8 and turn it into open bracket x plus 4 close bracket times open bracket x plus 2. So I just want you to get a rough idea of that, so we can move on into this. Alright, so for these examples, we're being asked to factorize the following quadratic expressions. Alright, let me move over to the other page. So for the first one, we have x plus 2, we have x squared plus 5x plus 6, and we're asked to factorize that. Now what we do in order to factorize this is, let me kind of show you something that you need to know. X squared plus bx plus c. If you notice, right, x squared would be a would be the coefficient of x squared, and b would be the coefficient of x, and then c is a constant. Now if you can look at this, we would have a coefficient of 1 right here. So in that case, a is equal to 1, b is equal to 5, and c is equal to 6, based on what is happening here. Right? So the next thing we would do now, in order to factorize this quadratic expression, we need to find two numbers. Right? Let's call those numbers h and s. Let's use s. We need to find two numbers, whatever those numbers are, that whenever you multiply those numbers, h times s, it should give you the product of a times c. It should equal a times c, whichever that number is. And whenever we add h plus s, it should give us b. Right? It should give us b. So we're gonna go on a little exploration now as how we're gonna find those numbers. Alright. So let's look at how to find this first, a times c. And in this case, we are saying that a is 1 and c is 6. Right? So 1 times 6 would be equal to 6. What are some other ways in which we can represent products as being equal to 6? We also have 2 times 3 equal to 6. Negative 2 times negative 3 also equal to 6, and negative 1 times negative 6 is also equal to 6. So we should choose two of these numbers that will actually multiply to give you 6 and also add to give you b, which is 5. If you notice, all the numbers here multiply to give you 6. All of them. So it's actually one of these numbers. So all the numbers multiply to give you 6. So we got that out of the way already. And then we need to find which two numbers multiply to give you b. And in this case, b is 5. Or which two numbers add to give you b. In this case, b is 5. So if you add 1 and 6, this would give you 7. So 1 and 6 are not the numbers. If you add, let me skip that one. If you add negative 2 plus 3, you would get a negative 5. Remember, we have a positive 5 and not a negative 5. But if you add 2 and 3, that would actually give you a positive 5, which is what we have here. So 2 and 3 are the numbers that we use. Now what you're going to do, you're going to go back to your original equation now, expression. And you're going to write x squared. But instead of writing the 5, you're going to substitute 2 and 3 into the function, into the expression. So the 5 would turn into 2x plus 3x, because we know if you add those, you would get back a 5. And you put back your plus 6. Right? So now we need to factorize each of these brackets. So we have x squared plus 2x for the first bracket. So we would factor out a x. This leaves x plus 2. And then here, 3 is common to both of those. So you would actually factor out a 3. Leaves x plus 2. Right? And if you notice, x plus 2 is common to both of these terms that are separated by the addition sign. So we can factor out a x plus 2 again. And we are left with x plus 3. Or in other words, you could just think of whatever is common to both sides, x plus 2, put that in a bracket by itself, and whatever is left with it, which is the x plus 3, you also put that in a bracket.